The ambiguous case of the sine rule is called the ambiguous case because in some triangles, when we are looking for a missing angle, there will be two possible solutions. Let's see an example of this. Imagine that this is the information that we are given, and we are going to draw the triangle based on this information. So first I will draw side AB. Which is 9 centimeters. I will measure an angle of 25 degrees here, and I will draw this side. This here, I know is 25 degrees. And I will draw side BC from point B. Well, and I know that BC is 7 centimeters, and I can draw two possible triangles with a 7 centimeter BC side. One looks like this, and the other one looks like this. Okay? I will name this point C1 and this point C2. So as you see, based on the information that we are given, we can draw two different possible triangles. So this here is 7 centimeters. And this here also is 7 centimeters. Okay. Now I will focus on triangle ABC1 to set up the sine rule and calculate C1. And this is how it will look like. I'm focusing on this triangle over here. So the sine rule for this triangle is 7 over the sine of the opposite angle. So that's 7 over sine 25 is equal to 9 over the sine of the opposite angle, which is C1. To solve this equation for C1, first I cross multiply, so this C1 comes over here, sine 25 comes over here, 7 sine C1 is equal to 9 sine 25. To get C1 by itself, I will divide by 7. And to get C1, I will use sine inverse or sine minus 1. Of course, when you enter this into your calculator like this, be careful and make sure that your calculator is in degree mode. If you do this calculation, you will get 32.9 degrees for C1. So from that we figured out that this angle here is 32.9 degrees. How can we find the other possible angle, C2, here? That's the question. Well, I see that the triangle C1, C2B, so this triangle here, is an isosceles triangle because it has 7 centimeters and 7 centimeters. In an isosceles triangle, the angles here, so this angle here, and this angle here will be equal. So this angle then is 32.9 degrees as well. I know that C2 is on the same line with the angle that we found here, 32.9 degrees. So then I know that this angle here is 180 minus 32.9 degrees, okay? Which gives me 147.1 degrees. If I round to 3 significant figures, I get 147 degrees. So this is how and why, when you're using the ambiguous case of the sine rule, in some cases you will get two solutions. The ideal is that you use the sine rule to find one of the solutions, and then you subtract the result from 180 to get the other possible angle. There's one more thing we have to check here, is whether this angle makes sense in this triangle. Well, let's check that. I will take 147 degrees plus 25 degrees, which adds up to 172 degrees. 172 degrees is less than 180 degrees, so it makes sense we can have a triangle that has these two angles in it, and then the third angle that I would get here would be 8 degrees. So this was an example for the ambiguous case of the sine rule.